Good evening, everyone. This is Sundaram from Final Year Biomedical Engineering. Today, my topic is about radiation therapy and radiation safety. In this topic, we are going to see about the thermoluminescent dosimeter and the packet dosimeter. So first, thermoluminescence. Thermoluminescence is a form of luminescence that is excited by the certain crystal material, such as some minerals, when previously absorbed energy from the electromagnetic radiation or another ionizing radiation is re-emitted as a light upon heating of the material. When a material is heated, some of the energy is absorbed previously. After some time, when we are heating this, a light will be emitted. So this is a thermoluminescence material. So for example, we have a material like for example crystal material. So it will absorb the radiation during the electromagnet, which is absorbed by electromagnetic radiation. After some time, we are going to heat that. During the heating, there will be the re-emission of light. So this is the property of thermoluminescence, which is emit the light during a heating. So next is thermoluminescent dosimeter. So thermoluminescent dosimeter is nothing but which absorbs the radiation and gives the amount of radiation is absorbed by the dosimeter and the exposure of radiation. So thermoluminescent dosimeter is a passive radiation monitoring device used to measure the cumulative dose of ionizing radiation received over a specific period of time. So it is a cumulative dose of ionizing radiation for the particular. It absorbs the radiation, cumulative radiation for a specific period of time which is calculated. It is widely used in the radiology departments, nuclear facilities and radiotherapy centers and environmental monitoring. It is worked on the principle of thermoluminescence which is explained before, with certain crystal materials emit light when heated after being exposed to the radiation. So the principle of some of the dosimeter contains storage phosphor in which a fraction of electrons is raised to the excited states by ionizing the radiation and trapped in the excited states. So a fraction of electrons must be present. So it is raised to the excited stage by an ionizing radiation. When we ionizing the radiation, it rises to the excited state and become that excited radiation will be trapped in the excited sites. So the principle of when these trapped electrons are released either by heating or exposure to the light. So the trap when these trap radiation will be released either by heating or when the exposure of light. When we heating that material or by the exposure of light, the electrons will be released. They fall to the lower energy stage with the emission of light. So while we are heating, it fall to the lower energy stage with the emission of light. When the emission of light is occurs, there will be the energy fall during the emission of light. So it is an excellent personal environmental dosimeter. They are somewhat more expensive and not widely used in the diagnostic radiology as a film bandages. It is personal environment equipment dosimeter. Somewhat this is more expensive, so it is not widely used in the diagnostic radiology. So the principle of thermal luminescence is when a TLD material, usually a crystals like lithium fluoride, is exposed to the ionizing radiation. So the radiation excites the electron in the crystal lattice. These electron moves to the higher energy level, which I have already explained, and trapped in the defects or impurities within the crystalline structure. It will trap. After that, when we are heating or emitting the light, there will be the release of energy. So this is known as thermoluminescence. The intensity of emitter light is directly proportional to the amount of radiation is absorbed. When an intensity of emitter light is which is directly proportional to the radiation absorbed. The radiation absorbed is directly proportional to the intensity of emitted of light. It is, we can say as it is as like this, and also inversely. The next thing is the most common used TLD materials for personal dosimeter is lithium fluoride. For the personal dosimeter, we are using the lithium fluoride. Why? Because the reason is it is tissue equivalent. It is spread equivalent to all the muscles. So wide dosage range. It will give wide dosage range, good linearity and stability, which was very stable. We can reuse it, which is sensitive to the different radiation, that is alpha radiation, gamma radiation, beta radiation. It is sensitive to the different radiation and it has minimal fading. So the construction of TLD is TLD material lithium, we are using the lithium fluoride, calcium phosphate doped with the dysprosium and calcium fluoride doped with the manganese. So we are using for the construction of TLD. Holder and badges, protective plastic and metal casing is there. It includes the filters like open window, plastic fiber, fiber, copper filter, etc. to differentiate the between beta, gamma and X-rays. So we have to, why we are using this filter is for differentiate the different types of radiations. So we are using this holder and bandage. Identification code, barcode or serial number for the tracking the wearer. So who wear that bandage? So for tracking that, we are using the identification code. So now we are going to see the working of TLD. First one is exposure. The TLD batches were worn by the radiation workers. The ionizing radiation will interact with the crystals and trap these electrons. So after that we have to read out how many amount or how much percentage of radiation is exposure or absorbed. After the exposure time, that is usually after 2 to 3 months, the bandage is taken to a TLD reader. We are going to take into the TLD reader. We are going to heat the TLD reader crystals. About how much Celsius we are heating is 100 to 300 degrees Celsius we are heating. After that, when we are heat that, there will be the emission of light, and during the de-excitation it will be trapped in the excited state. When we are heating, it come to the lowest energy, so it will de-excitation. So the detection, photomultiplier tubes, we are here to measure the radiation absorption. We are using the photomultiplier tube to measure the emitter light. So after that we are going to find the calculation of dose, how much is this absorbed. So the TLD leader is converts the light intensity into the radiation dose using the calibration factor. By using the calibration factor, we are going to convert, we are going to find out the radiation dose that is absorbed by the TLD. So the type of TLD materials, as I said already, that is lithium fluoride, because it can, the reason why we are using the lithium fluoride is tissue equivalence. So it will spread equally to the all muscles equally. For example, we are giving same for giving 10 amount of 10 CR something we are giving. So the 10 values will be equivalently spread to all the tissues. Okay. So it is most commonly be used in the radiation therapies at all. So the advantages of TLD is accuracy and sensitivity. It gives an accurate value and sensitive to the different radiations. So wide dose measurement, it can be reusable, which I have already said. So the disadvantages is no instant reading. We cannot be read the values instantly because we have to do some of the procedures like heating. While after heating only we are getting the values of a radiation dose. So there will be no instant reading. Second one is more expensive than film badges. So the compared to the film badges, the thermoluminescent dosimeter is so expensive. So in this thermoluminescent dosimeter, we cannot reread the values, which means we cannot see the values again, how much amount of radiation is absorbed by us. We can only use a single time only we can view the values. So we need a careful calibration for this thermoluminescent dosimeter. In this thermoluminescent dosimeter, we have the finger ring like dosimeters, which is used in the highest exposure to the pharmaceutical and preparation and administration. So longer dose assessment interval are required for this thermoluminescent dosimeter. So optical stimulator dosimeter. In this optical stimulator dosimeter, there we used heat to get an radiation values, which means absorption of radiation values. But in optically stimulated values, we are using an uh, mm, laser light to heat. Instead of heat, we are using the laser light to measure the radiations. How much radiation we have observed. In crystalline aluminum activated with carbon is commonly used because crystalline aluminum in this optically stimulated dosimeter, we are using an carbon and doped with crystalline crystalline aluminum is doped with carbon, so it is commonly used. So they have a broad dose response capability and capable of detecting a low doses also we can be measured. Then however, the OSL dosimeter have a certain advantages over the TLD. They can be reread several times. In TLD, we cannot reread the values, but in OSL, we can reread the values how much time we want. An image of filter pattern can be produced difference between a static and the non-dynamic exposure. So the static and dynamic exposure is, for example, a static dosimeter remains in a fixed position relative to the radiation source because the dosimeter has been fixed in a particular position. The radiation field around it does not change with the time. The radiation field will be around that dosimeter, but the time will not be changed. Where we are using this static dosimeter means personal dosimeter owned by the body during the routine work. Who are all working in a radiation field, they are in the routine work of radiation, so they are wearing that. Then hang this will be hang on the walls or fixed holders to measure the radiation amount of radiation that are exposed during the uh, performing a radiation work. We have used this static exposure dosimeter. In dynamic exposure dosimeter, it refers to the dosimeter where either the dosimeter of a radiation source is moving. Here, the dosimeter will move, so it will causing the, so due to that there will be the fluctuation of radiation intensity over the time. So because here in dynamic, static is stable, dynamic is movement. So static is fixed. So dynamic is in movement. So the radiation dosimeter will be moved to all around. So due to this, there will be the fluctuation of radiation intensity for the particular amount of time. So in radiation, where we are using this means a person who is revolving or surrounding, working, moving in the workplace. Okay. So this is about static and dynamic. So what are the application of TLD is personal dosimetry for radiology, radiotherapy, nuclear power plant, and industrial radiography. We are using as a personal dosimetry. For environmental monitoring, we are using measuring a background radiation levels in the soil, amount of radiation that is present in the soil, air, and water. In medical physics, you are using medical radiotherapy missions and in vivo patient dosimetry. In space research, we are using how much amount of radiation is absorbed or exposed by the astronauts. We are using dosimetry. So the next topic is about packet dosimeter. A packet dosimeter is a self-reading ionization-based radiation detection device used to measure the personal radiation dose immediately, typically used by the radiation workers, industrial radiographers, and emergency responders. So, from the word we have that a packet dosimeter. Packet dosimeter is nothing but we kept in a packet, so it will detect the radiations and it measures the personal radiation dose immediately. While they were designed to measure the X-rays and gamma exposure, they will also respond to the beta above 1 mega electron volt. So in packet dosimeter, they can measure above 1 mega electron volt. So the principle of packet dosimeter is it is based on the ionization chamber principle. So inside the device there is a small air filled chamber. So when the ionization radiation is enters, it ionizes in the air molecule and creating the ion pass. So the ionization reduces the charge and stored in an internal electrode. This change is seen in the movement of quartz fiber or scale indicator. The reading is shows directly in a dose in MR or MSV. So the thing is, the principle of a packet dosimeter is based on the ionization of air by radiation. Radiation. So the air get ionization. When the ionization radiation is enter the air-filled chamber, it produces a pass. So it produces ion pass, which is partially neutralize the positive charge on the central electrode. So this will cause a reduction in charge, the decrease in Coulombic repulsion. Cause this will attach to the quartz fiber and move closer to the electrode. So there will be the movement of fiber can be viewed through the eyepiece with a calibrated scale. So from that we can identify how much amount of doses exposure are absorbed by the uh, dosimeter can be measured. So the construction, typically a packet dosimeter contains ionization chamber, quartz fiber electrometer, charge board, electrode wire, viewfinder, and the protective housing. So cap with window. It allows the radiation to enter the device. It also protects the internal components from the dust and physical damage by permitting the radiation to pass through. And the second one is supporting insulator. It holds the internal wire which contains an quartz fiber. It prevents the electrical energy to maintain the charge of the dosimeter. Second one is wire element. A wire element is a part of electroscope mechanism. So it is a thin element which is present in the dosimeter. So it gets charged to know a potential and move its movement corresponding to the amount of ionization caused by the radiation. So it will get charged and move corresponding to the amount of radiation it is absorbed. Next one is quartz fiber. Quartz fiber is act as a pointer in an electroscope, which is in bucket dosimeter. A dosimeter is exposed to the radiation. The ionization causes charge to leak and the fiber portion shifts. So when the radiation enters, there will be the vibration. Due to that vibration, the fiber portion will be shifts. The next one is electrode. The electrode carries the electrical charge to the ionization chamber. This electrode will carry the electrode electrode carries the electrical charge to the ionization chamber, a conductive rod that maintains electrical potential inside the chamber. So there will be the conductive rod which produces electrical voltage inside the chamber. Next one is electroscope. Electroscope is used to detect the radiation to measure the ion pairs and that radiation is passed through the chambers. Next one is lenses. Lenses is to magnify the quartz fiber image and dosage scale to reading, and so by using the lenses we are seeing the measurement value, that is how much amount of radiation is absorbed by the packet dosimeter. Dosage scale, it will shows in the milli endogen and millisieverts to read the radiations. Scale show this position quartz fiber shows the accumulated exposure. The next one is eyepiece. Through the eyepiece, we are going to see the scale and quartz fiber. It works like a microscope. Small changes in the fiber position can be seen accurately. The case outer course components accurately. Case is nothing but which protect the inner components safely. Next one is gamma or X-rays, representing incoming radiation and enter through the window, ionizing the air molecule. Which this is the principle of the pocket dosimeter, which is a gamma or X. There are two types of dosimeter, that is thermoluminescent. MOSFET dosimeter, pin dosimeter. There are two types of electronic dosimeter. So these are the advantages, disadvantages, applications, principle and working of all the dosimeters, which is thermoluminescent dosimeter and packet dosimeter. Thank you. There will be two types of electronic dosimeter. One is pin dosimeter and one is